Welcome back to the Deep Dive. Today, Monday, October 13th, 2025, we're doing our rapid rundown of the top 5 AI stories hitting the news.
That's right. And it's quite a mix today.
It really is. Now, just so you know, this specific program called AI Daily Deep Dive was actually researched and put together entirely by AI.
Which is pretty meta, huh?
Yeah, definitely. Okay, so let's unpack this. 5 fascinating pieces of news that really define the current state of the AI race.
Where do we start?
Let's kick off with OpenAI. They've just announced a massive partnership with Broadcom. They're developing their first in-house AI processor.
Big move. Aiming squarely at reducing that dependency on NVIDIA,
Yes,
right?
exactly. It's a direct shot.
And the scale here is kind of wild. They're talking about needing 10 gigawatts for these custom chips.
10 gigawatts. Seriously, that's what, like millions of homes worth of power?
Over 8 million U.S. households, yeah. It just shows when you get to that scale, custom silicon isn't just nice to have, it becomes almost necessary, financially speaking. But the specifics of the deal matter too, don't they? It's not just about the chip itself.
Absolutely crucial. The deal actually specifies exclusive use of Broadcom's Ethernet networking tech.
Ah, okay. So that sets up a direct fight with NVIDIA's own thing, the InfiniBand solution.
Precisely. NVIDIA dominates that space currently. This is Broadcom, with OpenAI making a very deliberate play to challenge that, diversifying the whole stack.
Okay, interesting. Let's shift gears from, massive hardware infrastructure to something more consumer-facing. Google's Nano Banana.
Right, the image editing AI is part of their Gemini 2.5 Flash suite.
And it's expanding its reach.
Yeah, they're integrating it into Google Search now, through the Lens feature, and also into NotebookLM, their AI research tool.
So right in search, you can, edit images?
Kind of. It lets you do contextual image transformations. So you could take a photo and apply, say, a watercolor style or an anime style. There are 6 options.
Okay, cool. And in NotebookLM?
It's powering these new visual summary features. They call them video overviews, and also a new concise format just called brief. Helps make sense of research material visually.
Got it. All right, pivot again. Let's talk defense tech and Dural Industries.
Yeah, they just debuted something called Eagle Eye at the AUSA meeting. It's an AI-powered headset for soldiers.
More than just fancy glasses, I assume?
Oh yeah, it's designed as an edge AI system. The idea is to run mission command models right there on the soldier. And it's modular.
Modular meaning?
You can clip on different sensors depending on the mission, like maybe a hyperspectral camera if you're an EOD technician needing to identify materials.
And they've thought about the practicalities, like weight and balance?
They have. Apparently the most promising version uses ballistic AR glasses, but they've mounted the processor, the battery pack, onto the helmet itself. Better balance, more comfortable presumably.
Makes sense. And for the military, everything needs to talk to everything else, right? Interoperability.
That's key. The whole system uses a common software architecture that's actually mandated by the Army under something called the SBMC Architecture Contract.
So standardization is built in from the start.
Exactly. Ensures different pieces of kit, even from different makers potentially, can share data and AI insights seamlessly.
Okay, this kind of leads into a more philosophical debate happening in AI. We saw an article pushing back against the scaling hypothesis.
Ah, yes. The idea that just making models bigger and throwing more data at them will automatically get us to artificial general intelligence, AGI.
Right. This article argues that's maybe not enough, so what's the alternative?
It's being called the curated knowledge hypothesis. The core idea is that we need to deliberately encode structured conceptual knowledge, the kind of stuff humans learn progressively through education.
Like teaching it concepts, not just patterns.
Exactly. Think about the concept of the number 5. Not just seeing the digit 5, but understanding fiveness, whether it's written, spoken, or shown as 5 objects in an image. Really grasping the abstract concept.
So the strategy there isn't just scale, it's careful teaching.
Pretty much. Curating these core educational concepts, having human experts rigorously test if the AI actually understands them, and then applying that understanding in real-world tasks. It's much more deliberate.
Fascinating. Okay, last story. And this one brings us right down to the metal, so to speak. Assembly language is making a comeback.
Kind of surprising, right? The absolute lowest level programming language, the one that talks directly to the hardware.
Why now? Isn't everything about high-level abstraction?
Usually, yes. But the brutal truth is, for maximum efficiency, assembly gives you unmatched direct control over the chip's operations. And in AI, efficiency is suddenly paramount.
So are companies actually using it?
Oh yeah, DeepSeek, a Chinese company, reportedly used assembly to optimize how data is handled on NVIDIA chips, like squeezing data from 32 bits down to 8 bits at very specific critical moments.
Wow. Any other examples?
DeepMind did something similar. They actually trained an AI to use assembly language to optimize a very common mathematical function.
They taught an AI assembly.
Yep. And the savings per operation were tiny, fractional. But when that function runs billions or trillions of times across their servers, those tiny savings add up to massive efficiency gains overall.
Okay, so tying this all together, what's the big picture for you listening today?
Well, I think today's news really throws a core tension into sharp relief. You've got the simultaneous push for just massive scale look at OpenAI's 10 gigawatt chip plans.
Right, sheer brute force infrastructure.
Exactly. But then you also see this intense focus on hyper-precise, low-level optimization, like using assembly language, and this deeper conceptual understanding needed for things like the curated knowledge approach to AGI.
Power versus precision, almost.
You can put it that way. So the final thought maybe is this. Thinking about OpenAI's enormous new power needs. Is the future of AI going to lean more towards that sheer electrical power and scale? Or will it depend more on achieving that intimate, almost human-like understanding of concepts and hardware that we also talked about today? Where does the balance lie?
Something to definitely keep an eye on. That's our deep dive for today. Thanks for joining us.